right, you might have seen this yesterday. I'm just going to go through it in case people did not see this. So this is C of x. So this is C of x. So you're putting a minus 4 into C of x. Use that. So you're putting a minus 4 into there, and then you're timesing it by 3. So I'm going to come over here, and I'm going to do this. So I would have a minus 4 times a minus 4 times a minus 4 minus 2 times a minus 4. So a minus 4, I'm going to only times two things together at a time. A squared minus 8a plus 16. And then I'm going to times that by the a minus 4. So a cubed minus 4a squared minus 8a squared. So I did those two. Now I'm doing these two plus 32a. And then I'm going to do the 16 plus 16a minus 64. So now I have like terms. I have a minus 12a squared plus 48a minus 64. And then I'm timesing that all by 3. So 36a squared. I don't know, 48, 96. 96 and 48, I didn't bring a calculator in here, is 144. Should have known that. And then 64, 128 is 192. And you'd have your calculator. But I'm not even done yet. Oops. Because I still have to do this part, which is minus 2a plus 8. So that gives me 3a squared minus 3a cubed minus 36a squared plus 142a minus 184. Okay, that just takes care of that. Now I'm going to come and I'm going to do 3 times, this is my d, so these are going in here and here. So I'm going to come up here and I'm going to say, okay, 3, and luckily it's a plus sign. 3 times 4 times a plus 5 and a plus 5 minus 6 times a plus 5 plus 8. And I'm doing that whole thing times 3. So a plus 5 and a plus 5 is a squared plus 10a plus 25 minus 6a minus 30 plus 8, and then I got to times all of that by 4, plus 40, 40a, plus 100, minus 6a minus, let's go 22 and put those together. Okay, and so I'm going to times by 12, or 3, sorry, and I'm going to multiply, combine like terms. So that's 12a squared. Here's 40 minus 6 is 34. 34 times 3 is 102. Hopefully I didn't do math wrong. And then that 78 times 3, I cannot do 78 times 3 without a calculator. 4, carry the 2, that's 23, 234. So now I'm putting like terms together. 3a cubed. A negative 36 plus 12 is a negative 24a squared. 142 plus 102 would be 244. And then I don't know what this is. Hopefully I don't get it wrong. It would be 0, borrow, what is that, 50? So, and it would be plus 50. Okay, so something like this that's in your homework, we've done a couple examples with this one was from yesterday. I'm just finishing it up, but you're definitely going to have to practice these. Okay, so please do not skip these in your homework. Okay, these are definitely ACT type questions. All right, go ahead and pause and try this one. Pause, try it. I would definitely reduce the inside before I did anything. And then I would flip it because it was negative. And so then my answer is x to the 6th over 25. If you got that answer but did it differently, then your way is correct. Okay, same thing. Do this one, pause and try it. Okay, I would put my like terms together first because it's all multiplying. So x to the negative ninth, y's would cancel. So my answer is a negative 20 over x to the ninth because the 20 isn't a negative exponent, it's a negative number. All right, pause and try this one. Okay, so you're doing, if I put a 1 here, this would be a negative 8 to the negative 2, x to the 6th, y to the 8th, times 2, that would be 16, x to the negative 6, y to the negative 6th. So this right here would be 1/64th, and it would be positive because it's to an even exponent. So then if I put these two numbers together, 16 divided by 64 is 1/4. My x's would cancel, and when I add exponents, I'd have y squared. So if you did that one differently, but got the same answer, good job. All right, pause and try this one. So 12/5 doesn't reduce, and then it's going to be x to the 7th. Okay, try this guy. Two, 4, 8, 16, 32. And a negative number squared is going to become a positive. So on the top, I'd have 64, x to the 13th, over 36, x to the 6th. I believe 4 goes into both of them, 16 ninths. And I'd have 7 left up here. So that is my answer. All right, and we did that. I think we talked about these. I'm going to let you guys pause it and see if you've done it, fast forward through it. But the volume of the box is given, and they also give you the height of the box, and they want the area of the base. Well, isn't your volume the area of the base times the height? So if you divide both sides by the height, wouldn't that be the area of the base? So I'm going to do x minus 1 into this. So I look at my front numbers. How many times, what would I multiply x by to get x cubed? X squared, that would be x cubed minus 1x squared. I change my signs. You can do whatever you want. And I get 4x squared, and I bring down. How do I change an x into a 4x squared? You times it by plus 4x. So it gives me 4x squared minus 4x. I change my signs so I don't screw up. So that gives me 3x. Bring down the 3, and this would be a plus 3. So 3x minus 3. Change your signs, you get 0. How did you know by the story problem you should get 0? Because it said it was the height. So then it's going to go in evenly if it's the height. So that would be the area of the box. All right, so let's talk about some vocabulary here. The location principle is basically when you're looking for the location of zeros, roots, and things like that, is it's saying that as a y value changes from increasing to decreasing or decreasing to increasing, a max or min is located. Oops. Okay, a relative maximum is the highest y value in an area. Okay, so you could have several relative maxes on a graph. Okay, is the lowest y value in an area. Okay, absolute, if you think about this, absolute is like absolute power. There's only one. So this is the highest point on the graph. Not all graphs will have them. And this is the lowest point on the graph. Okay, and then finally, this is kind of like root solutions. In later classes, when you need to actually use this for more than what we're doing, they'll give you better definitions, but I just want you to know this is just basically those, the relative, maxes and mins. Because an absolute max is a relative max. It's the highest in the area and it's the highest on the graph. So it's a special one. So if they ask you to label it, you would say absolute. But if they ask you how many relative there are, you would count the absolute. And so that's what we're going to kind of talk about right now. Just like a square is a quadrilateral. Okay, so it wants you to graph by making a table of values. So if we think about this, I have an x, I have a y, I know I have a point at 0, 5. I know it's a degree 3, so I'm going to kind of graph. I know it's going to go downhill somehow. The most it could hit the axis is 3 times. So we're going to try to get this graph by plugging in points. So when I plug in 0, I'm at 5. So I'm going to go ahead and plug in 1. 1 cubed, that would be a -1 minus 4 plus 5. 0. Okay, when I plug in 1, I'm at 0, so it's going down. When I plug in 2, that would be a -8. And then that would be 4 times 4 is 16 plus, okay, that thing is shooting down, right? The more numbers I put in, it's just going to continue to go down. So I'm going to go the other way. I'm going to plug in a -1. -1 cubed is a -1, and a negative is a positive. And then it would be -4 plus 5. So that would be 2. So I have a point at a -1, 2. So now it's kind of in this part of the graph in here. It's going down. Once I get it to go back up, then I'm done because I've gotten the whole thing. So I'm going to plug in a -2. That would be a -8, but then I'm doing a negative of it. So it's 8 minus 16 plus 5. So that would be a -3. So it's still going down. -2 is at a -3. So it's kind of going up here and it's going down. -3, that would be a -27, but then I'm taking the negative, so 27. 9 is a -36 plus 5. 27 plus 5 is 32. No, 33, sorry. 27 minus 36. Is that a 4? Yeah, it's a -4. Okay, so that's kind of, I think the next one I'll be done. A -4. I'm just going to use so we can keep going. I'll just go down here. -4, go, -4 would be -64. And 4 squared is 16. And so it's going to be minus, no, it's going to be a positive 64 because it's a negative. Minus 64 plus 5. So this answer is going to be 5. And so now it's coming back up again. So it turned in here and it's going back up. Okay, so there's my graph. It's no calculator. It's just getting an understanding. These are not going to, this is one of those assignments again, where you are going to be expected to graph these without a calculator. So, and you're going to have some hints and stuff as you're graphing it, but you got to practice these. Okay, so on this one, I would like you to graph it without a calculator. So if you look at it, I know that the y-intercept is at 1, and I know it's a cubic, so it's going to do something like this. So once I get that shape, I'm going to be done. So I put in 0, I put in 1, that would be 1 plus 2 plus 1. It's 4, so I have a point at 1, 2, that's 2, 3, 4. And if I put in 2, that's 8. Plus 8 plus 1. Okay, that thing seems like it's in this area, like it's shooting up. So I'm going to come back to -1. That's a -1 plus 2 plus 1 would be 2. Okay, wait. So I'm at a negative 1, 2. That must be kind of in here. I'm going up. Negative 2 would be a negative 8 plus 4 times 2 is 8 plus 1. Okay, so now I'm going down again. I'm done. That got me going down, and this is all I need from you is just the shape of the graph. Okay. All right, so determine the consecutive values of x. So we did this last chapter. I would never accept this on the test. Some of you tried. You know this is a degree 4 and it's got a positive a value, so it's going to do something like this. So once we get it shooting off to infinity, we're going to be done. Okay, so this thing I'm going to start at 0, 1. Okay, and I'm going to put 1 in. That's 1 minus 4 plus 1. So that's that cancels. So negative 3. So I just crossed the axis, didn't I? So I have a root. I have a root happening because it was at 1 and now it's at a negative 3. Then I'm going to put 2 and 2, 4, 8, 16. Okay, and then I'm going to have minus 8. 2 squared is 4, so minus 16 plus 1, that's a negative 7. Okay, and then I need to kind of get it to go back up. So at 3, 3, 4, 3, 9, that's 81. 3 cubed is minus 27, minus 36, plus 1. This is going to be, I don't have a calculator in here, but this is a positive big number. So it must cross again, and then it's got to be shooting up because it's when you fourth something, like 4 to the 4th is way bigger than 4 to the 3rd. So there's another root in here, so root 2. Okay, so I'm going to go the other direction because now I know that it's shooting off to infinity. So I'm going to put in a negative 1. That would be 1. Negative 1 cubed is a negative 1, so plus 1. Minus 4 plus 1, so that's a negative 1. So negative 1 is at a negative 1. Okay, so there's another root, root 3, right? And I'm going to get these decimals later, so I'm going to do a negative 2. Negative 2, 4, 8, 16. That's 16 plus 8 because it's a negative. 2 squared, so minus 16 plus 1, that's 9. So that crosses 1, 2, 3, 4, 5, 6, 7, 8, 9. That's like way up here. Oh, that was too far over. So I'm going to cross and I'm going to cross. So here's my other root. So there is my 4 roots. Okay, so just like last chapter, if you had a good understanding of this, it was easier when we took the test. I will not accept between for answers on the test. We're going to actually figure out how to find the exact ones. Okay, so consecutive zeros. If you look at this, this is a cubed. So I'm looking for 3 zeros. I know my first one goes through at 2. So 0, 2. If I put in 1, that's 1 minus 4 plus 2. That's a negative 1. So 1 is at a negative 1. It just crossed. Root 1. Okay. And then if I put in 2, 2 cubed is 8. Minus 16 plus 2. So negative 6. So I have a point at 2, 3, 4, 5, 6. Okay. And then if I put in 3, 3 cubed is 27. 9 minus 36 plus 2 is a negative 7. Then if I put in 4, 4 cubed is 64. 4 squared is 16 minus 64 plus 2. So that's a 2. So it just crossed again. Okay, so it's kind of going down and then it crosses. I know it's got to shoot off to infinity. Okay, so now I've just found my other root. So root 2. Okay, so I'm going to go back this way. Negative 1, that would be a negative 1 minus 4 plus 2. So that's a negative 3. I just found my other one. 1, 2, 3. And that's all of them. I can quit because I'm looking for 3 roots. So I have a root between a negative 1 and 0, a root between 0 and 1, and a root between 3 and 4. Okay, and I think you guys, I'm not going to do a bunch of practices of this. All right, this one you do need to read and kind of take a look at. There's a couple of these questions in your homework and in the textbook. So sketch a graph with 3 unique real roots. Unique means they're different. Okay, and 2 imaginary. So I need to see the imaginary. So I'm saying 3 unique real roots. I don't really care. So 1, 2, 3. And then an imaginary, it's a negative leading coefficient. So isn't this a degree 5? Because you have 5 roots. So that means it's got to come down and then maybe it bounces before it does this. Okay. So I've got to see this bounce in here, that it is an imaginary root, because imaginary root will cause you to have another vertex in there. Okay. That's, or I could make it go like same thing. Well, I'll just use a different color. So I can make it come here, go back up, have the imaginary there, and go down. Like, I don't really care. There's a lot of answers, but it's going to hit the axis 3 times and then have either a bump above or a bump below. All right, so look at this one. A double root means you have a vertex on the axis, and then you have 1 unique root, so it's a different root. So that means that this is a degree 3. Okay, and it's a positive A value, so it's going to be going uphill. So I maybe have a double root here and then there, right? Or I could actually go through and have my double root there. I don't really care how you draw this, but it's going to have a vertex on the axis. Okay, graph with zeros at 1, at 3, and a double root at a -2 with a positive. So that means that it's got to go boom and through. So it's going to look like that. Okay, estimate the extreme zeros, smallest degree, blah, blah, blah. So the smallest degree kind of gets kids, and this is back in your notes. This is definitely a degree 4. It could be a degree 6. We don't know where your imaginaries are. It could be a degree 8. It could be because it's going down at the end, so it's got to be even. I definitely know it's not a degree 2 because I have a relative max right here. I have a relative min right there. And I have an absolute max right here. Okay, so those are my extreme values. And you can, it says estimate. So if I estimate this point, this is going by tens, 10, 20. I'm going to say this point is like 27, comma, -1. I'm going to say this point right here is like 19, -1.1. It's an estimate. And then this last point looks like it's pretty decently close to 0. So I'm going to say like 0.2, comma, 40-ish. Right? Okay, and so my zeros are right here. This is around, we'll say about 0.8-ish because it's an estimate. And this one is around -1.2-ish. And then my domain would be a -infinity to infinity. With parentheses, my range is a -infinity to about 40. Okay, go ahead and put the bracket because that's whatever that max value is. Okay. All right. So I would like you to try this one. Pause and try it. So my extreme values, this is going up by 5. So this would be 1, 2, 3, 4. This point right here is about a -4.3. And then 5, 10, 15, 20, 30, 35, like 38, -38-ish. Okay. And this is an absolute min, because it's the lowest point on the graph. Okay, this point right here is really close to 0, and it's probably about 4-ish. And then I have a point right there that is at a min, so this is a relative max. I'm going to have to label these. This at 2, 0 is a relative min. Okay, and then you have the smallest degree would be, my zeros would be 1, 2, 3, 4, 5. So -6, 0, and a -1, 0, and 2, 0 are my zeros. My smallest degree would be a degree 4. It could not be a degree 2, but it could be a degree 6, 8, 10. That's why it says smallest. without an equation, we don't know where the imaginaries are. My domain would be a negative infinity to infinity, and my range would be about what, negative 38 to infinity.